LOSAF is an open source security automation platform for multi-cloud detection. In this video, I'm going to show you how this platform works end to end. Now, we have different layers in this platform. So the first layer we have is collector. So this platform collects logs from multi-cloud environments. So it's going to collect log from what? From AWS, it's going to collect log from Azure, and it's also going to collect log from what? Kubernetes end. Then apart from collectors, we also have what we call normalization. Now, the normalization is to actually package all the old log into a single schema so that it can easily detect any threats that's within those multi-cloud environments. Then apart from normalization, we also have Mitre Attack layer. The Mitre Attack mapper layer, this is going to map each of those threats against real attack techniques and patterns. So in order to be able to detect the kind of attack key shape. Then apart from the Mitre mapper, we also have the detection layer. So the detection layer, we have detection layer for AWS, which is written in YAML. We have for Azure. We also have for Kubernetes. And all the results is going to be displayed in the dashboard in real life. So let me walk you through how this thing actually works in real sense. So this is how this platform works. I'm going to start from the collectors. So starting with the AWS collector. So now for the AWS collector, we API call to the cloud tree to fetch log. And if there is no credentials, it is going to actually fetch a mock cloud tree log for me. So let me run AWS log. So I'm going to say npm run collector. So the collector I'm running is AWS. So this is actually going to fetch AWS log for me, and it is going to inject it into my Postgre SQL in my Superbase. So now, as you can see, it has actually fetched the events from the cloud tree. So from this, we have two events from AWS. So you can see we have the event for create access key. Somebody created access key. We have the one for console login. Somebody logged into the console. So those are the two events that we're able to fetch from the cloud tree. Now I'm also going to fetch log from Azure. So AWS. So npm one collector Azure. So here I have two events as well. I have two login events from the Azure. Now making 4 events in total. So now let me also collect log from the Kubernetes. So I'm going to say npm run collector. Then this time around is going to be for Kubernetes. So we have 4 events now. So let me run now from the Kubernetes. We could get 3 events, and we can see we get an event of execution from a service account name attacker. This is the kind of event that may get buried in Kubernetes audit log. So now we have 7 events. After the log has been collected, the next thing is normalization of all the audio logs events. So I'm just going to say npm on normalizer. So this is going to put all the logs event into a single schema. So let me run that. Now from the result of my normalizer, I could see that we have normalized 7 events in total. We could see 1, 2, 3, 4, 5, 6, 7. Now from the event, I could see this Azure enter user login. Now I could see that the 70 is set to high. And the reason is because the mock IP of this actually matched with a known store exist IP. And the location is also from restricted area like Russia. And that is why the 70 is mapped to be high. You could see that this one is low. The reason it is low is because its own IP doesn't match with a known store exist node. And the region or the location where the login takes place is not restricted. So that is why this one becomes low. And we could see that port execution here is critical and 70. We can see the 70 as critical here. And we could see medium here for Kubernetes. We could see for object creation, we could see medium as well. These two object creation, they are medium. And for AWS Cloud Game, we could see 70 here high, which is credential creation, meaning that somebody created access key. And we could see when somebody just log into the console, it's just 70 is medium. So this normalizer is actually working perfectly. So after we have normalized all the events, the next thing now is to map them into Mitre Attack. Now I'm going to map them. So for me to map them, I'm going to run my Mitre mapper. So I'm going to say npm run mapper. From the result, we could see that 7 of the normalized event has been mapped into Mitre Attack. So let's check the report. So from the report, we could see the total event analysis is 7, critical 1, high 70, medium 3, then low 1. We could see the risk score. The average risk score is 82. Now these are the Mitre technique detected. We could see it here. Valid accounts. We could see it. Escape toast. We could see it. Now we could see the tactic distribution. Then we could see the top threat actors. Then we could see the data source. So you can see from Kubernetes, Azure, and what Cloud 3. Now this is the detail. Now we could see that C611 is what is escape host, and it came from Kubernetes for DT log. You can see it, and this was the action platform object version, and we could see the severity medium, and we could see the risk score as 90, and the tactic is what privilege escalation, and we could see this one and this one, they are the same thing. Okay, let me go down. Now we also have C1C09, which is container administration command. So that is the Mitre Attack. You could see. Now we could see the tactic execution. We could see the risk score. You can see the action platform called execution. Also, we have C1078, which is for valid account, and this happened on the Azure. And we could see the risk score, and we could see the severity as low. Now for this one, so we have C1078. They're almost the same thing. So valid accounts, we could see severity high. Then we also have risk score 75. So we could also see unsecure credentials, which is T1552, and this one came from AWS. Credential creations, meaning that somebody created access key, and we could see the risk score, and we could see the severity, and this is the total reports complete. You can see it here. So these are Mitre Attack mapper. So now our unified threats has been created. So it is time for us to detect the real threats. So now I'm going to run a detector engine that is actually going to run against each of these Mitre Attack events. It's going to run against each of these Mitre Attack events, and it's going to flag anyone that actually correlates with it. So my detector engine is going to run each of these detection rule against each of these 7 events, and it's going to flag anyone that is suspicious or that is a threat among them. So let me run my detector. So I'm just going to say npm run detector. The result of our detector, you can see LOSAF detection engine. So these are the detection rule that is run: AWS, login, identity, then Kubernetes, and we could see found 7 Mitre map events to evaluate. Now out of the 7 events, you could see that it was only able to flag 2. You can see. So 2 rule fire across 7 events. You can see here. Now let's look at the rule that are fired. You can see that it actually fired this one. Kubernetes escape. You can see it now. Pod execution. It fired this one. You can see, and we can see the score. The score 100 out of the 50 threshold. You can see it here now. And we can see the Mitre Attack, and we can see the response. The response is to terminate, and it is automatic termination. So in the advancement of this platform, there will be auto remediation. So as the score is 100 now, automatically it's going to terminate such pod. So in the advancement of this project, but in this project, this one is only based on detection. Then also, if you look at this privilege escalation that happened in AWS, now we can see that somebody actually created the credentials. We can see access key, and we can see the weight score is 70 out of 40 threshold. You understand? So in a real sense, this should be revoked automatically. You understand? Should be revoked, or a SOC analyst need to approve it. You understand? To see whether it is needed to be created or not. So in this case, in the advancement of this platform, there will be human in loop, whereby a SOC analyst we have to approve it or reject it to be created before the real action is taking place. So these are the 2 major threats that was fired. Okay, so now it is time for us to see it live in the dashboard and see how it looks. So I'm going to start up my server. So that's cd then API. So then I'm going to start up my server npm run dev. So this is okay. Now my server is on and it is working. So let me run the front end dashboard. So I'm going to go to another terminal. I'll just say cd dashboard. I'm going to navigate to the dashboard where I have my front end. I'm going to run the front end npm run dev. My front end is already running. So let me open it in the browser so we can see our result. If I open it here, boom, we can see. Now we can see now that our results has been loaded. So from here, we have 2 critical alerts, which are the 2 major alerts that were our detection rule flag. And we could see one is from AWS Cloud 3, and one is from Kubernetes. None of Azure events were flagged because none of them were threats. And we could see out of the 3 Mitre Attack that we have, 2 ran out of 3. And we could see immediate action required for SOC analysts. So this is the first place that SOC analysts actually need to take note. So, and this is what they need to actually immediately to revoke credentials. If I go down, I can see so this is for AWS and this is for Kubernetes. You can see. So you can see we can see and the response terminate pod and revoke credentials. You can see, and we can see the severity. This is high. This is critical. We can see the Mitre Attack mapping. You can see it here. You see it, and we can see what actually happened. Unsecure credentials was created. Then here, so we can see what happened. Container administration. Container administration was what was actually accessed. Now, this multi-cloud unified detection pipeline doesn't come from anywhere. It actually came from this legacy single cloud system. So this is a legacy SOC platform that actually created in Azure. So this is only narrowly to Azure. So this can actually detect and can actually automatically remediate. And see, so these are some of the tests I've done. So on this, I actually upgraded this saw into a multi-cloud detection pipeline like this. So the essence is just to make sure that we have an open telemetry for detection and remediation of threats in order to prevent lateral movements and to reduce blast radius within the cloud environment. So this is actually the GitHub page. Anyone can go there, clone it, emulate it, just the way I've done in this video. In conclusion, LOSAF is an open automation framework which helps us to collect log from different cloud providers. It helps us to actually normalize them into a single schema, and it also helps us to map them into Mitre Attack, and it also helps us to detect and flag for suspicious activities. Thank you, Linux Foundation.